Today we will see how two microservices talk to each other asynchronously. So there are three components which are included. One is two microservices on both ends and another is a queue. I have used SQS here. Later we will see how we can embed RabbitMQ or Kafka in between. So I have exposed an API using Express generator. So it's very simple. We can just do npx express generator and then npm install and then npm start. And in between we had SQS microservice queue, which will receive the data from microservice 1. So all the data from microservice 1 will be pushed to this queue. And then we had our microservice 2, which will be pulling data from this queue at a time interval like 15 seconds or 1 minute, or like it may be at night 9 o'clock or 12 o'clock when the load is less on the server. So this is our microservice 1. So here what I did is like I had created a router. So I had used here port 3000. If you go to bin www, all are default created by Express generator. I haven't changed anything here. Even in app.js also I haven't changed anything. I just removed the index one that is not required for me. I am just concentrated on user API. So user will route to user router and user router is being routed to users.js. So here the basic /users. In post method I will accept in body name and age and I will save it in that queue. So save address, which returns a promise. So here I have used AWS SDK. Instead of this we can use RabbitMQ or Kafka to store our messages. So in order to install AWS SDK, what we need to do is like we need to add AWS SDK here, or we can do npm install AWS-SDK. So in npm registry, if we search AWS SDK, you can directly install npm install AWS SDK. So if you go to address services, here I have mentioned the queue URL and I am passing the name and the age in username and user age in message body. So if you go to user.js, here we can see that we are passing name and age to save address, name and age, and this is being put in the message body and the URL is this URL. So if you want to verify it, we can go to our SQS management console in AWS, and if we click it, we can see the URL is the same URL which we are using in the REST API. So I will just make this queue empty. Oops, I have deleted the queue. Let me quickly create the queue. Okay, the URL got changed. We need to update the URL. And we will start the server npm start. So it's running. If you go to the queue and view and delete message, start pulling, we can see that it doesn't have any message in it. So what we'll do is like we will push a user. So here you can see that localhost 3000 users and I'm pushing my name and my age. Yeah, I'm kind of getting old. And we are using post method. So once I send it, there may be some error. No error. Connection refused. Why, man? Why this collaborator? Okay, my bad. I will resend it again. Oh, now it's successful. 200. Okay, so it should be 201 because we had saved it and we had received the message ID. This is of less important. So if we go to the queue now and start polling, so we can see that we had received the message, and if we click the more details, we can see the message ID that we had received here. It's the same message ID. Yeah. So this is one part of communication. The microservice 1 is tunneling or pushing all the messages to a queue. Later we can have multiple services like microservice 2, 3 and other batch services which will keep on polling data. So it may be real time or it may not be real time. In general, it is not real time. If you want to make real time, then we need to do like microservice 1 will push the data directly to microservice 2 through an API. So here I have this microservice 2. It is also using AWS SDK to fetch the data from the queue. And here I am just receiving it. So after the message has been received, what we need to do is like we need to save the data. Save it to database or perform some business logic. So we can either call another microservice or push it to its own database. So each microservice will have its own database. So all these I have kept default, like I am using region Mumbai and credentials are loaded from AWS config. So let me go and run this. So we can see that it is running every 1 second. So we can change it to 15 seconds and restart the server. So here I have not written the delete logic. So what we need to do is like once the business operation is successful, we need to delete this because else it will keep on fetching the same data again and again. So it's almost 15 seconds. Come on, fetch the data. Come on, come on, come on. Yeah, so you can see that the data has been fetched. Now there is another part. So microservice 1 is pushing the data to the queue. So there may be multiple microservice or multiple applications who wants to push its data to the queue. So we can directly go to the queue and send a message like hello. And close it. So it has fetched both the messages after 15 seconds. So we can see that it will keep on repeating itself because we are not deleting it. So this is how asynchronous communication between two microservices works. So there can be multiple input microservice, there can be multiple consumer microservice. So that's all for this tutorial. If you like this video, then don't forget to hit the like button. If you have any confusion, then let me know in the comment section. See you again and don't forget to subscribe.